Good day, everyone. Welcome to another session of Teaching on Air. I am your teacher for today, Ma'am Leanna. We are now on week 5 and we will discuss about application of sequences. And our learning objective, after going through this lesson, you are expected to solve problems involving sequences. The concept of arithmetic and geometric sequences can be modeled in real-life situations. That is why these lessons are essential. And this video lesson will help you find solutions to solve problems involving sequences. To solve real-life problems involving sequences, remember the words see, plan, do, and look back. Let us have this illustrative example 1. Suppose the auditorium of the Tagaytay International Convention Center or TICC has 20 seats in the first row and that each row has 2 more seats than the previous row. If there are 30 rows in the auditorium, how many seats are there in the last row? So the first thing that we should do is to see what kind of sequence is involved in the problem. It is very important what kind of sequence is involved in the problem. So if we go back to the problem, it has 20 seats in the first row. So our sequence starts at 20. And that each row has 2 more seats. Each row, so from 20 plus 2, we have 22, plus 2, 24, plus 2, 26. So if there are 30 rows in the auditorium, how many seats are there in the last row? So we are looking for the 30th row. How many seats are there in the 30th row? So that is an arithmetic sequence with a common difference of 2. So how do we get the common difference of 2? So that is a sub 2 or the second term minus a sub 1 or the first term. So that is 22 minus 20, that is 2. Or we can use the third term minus the second term, 24 minus 22, that is also 2. So that's why the common difference is 2. So after knowing what kind of sequence is involved in the problem, we will plan what is the appropriate formula to be used and the needed values. Since it is an arithmetic sequence, we will be using the formula for finding the nth terms of an arithmetic sequence. That is a sub n equals a sub 1 plus the quantity n minus 1 times d, wherein a sub n is the nth term, a sub 1 is the first term, which is 20 or 20 seats, and d as the common difference, which is 2, and n as the last term or the nth term that we are to find. After knowing the formula, we will perform the indicated operation and simplify. So that is a sub n or a sub 30 equals a sub 1, which is 20, plus the quantity n minus 1, n is 30 minus 1, times the common difference. So 30 minus 1 is 29, following the PEMDAS rule. So 29 times 2, that is 58, plus 20, that is 78. So that gives us the last row, 78 seats. So if we're going to look back, so this is the checking part. So we will see if the answer should satisfy all the given information in the problem. So if we're going to enumerate or list down the number of seats per row and see if the 30th row is 78, this will happen. So it's just that we made a shortcut of verifying this or getting these numbers using the formula. Now let us have another example. Using the same exact problem in example number 1, but instead of determining the number of seats in the 30th row, we are asked to find the total number of seats. How are we going to do it? So finding the total number of seats is solving for arithmetic series or sum of the given sequence. So that is given the formula S sub n, S for sum, and that is equal n over 2 times the quantity a sub 1 plus a sub n, or S sub n equals n over 2 times 2 times a sub 1 plus n minus 1 times d. So in this formula, n is the number of terms in the sequence. A sub 1 is the first term of the sequence. A sub n is the last term or the nth term of the sequence. And d is the common difference. So going back, let us see what are given in the problem. So in the problem, we have a sub 1, which is 20 seats or the seats in the first row, and n, which is 30, or the total number of rows in the auditorium, and 2 as the common difference. And based on the given, we can say that the appropriate formula to be used and the needed values is S sub n equals n over 2 times 2a sub 1 plus n minus 1 times d. So performing the indicated operation and simplifying it, so S sub n equals n over 2 times 2a sub 1 plus n minus 1 times d. So substitute natin. We have n is 30, a sub 1 is 20, n is 30, and the common difference is 2. So 2 times 20 is 40, 30 divided by 2 is 15, and then we have 30 minus 1 is 29, and then times 2. So 29 times 2 is 58. 40 plus 58 is 98. And 98 times 15, that is 1,470. So the total number of seats from the first row to the last row is 1,470. Let us try to solve this using the other formula. So, given the other formula is S sub n equals n minus 2 times a sub 1 plus a sub n. So, a sub 1 is the first term, and that is 20. So, 20 seats. While a sub n, upon solving it on the first example, that is 78. So, instead of having the long formula, since we already know that the last term is 78, we can use this. So, n is 30. That's the number of rows. So, 30 divided by 2, that is 15. And the first term is 20 plus the last term is 78. So, that is 98. 15 times 98, and that is 1,470 as the total number of seats. And to look back, or for our checking, the answer should satisfy all the given information. Since we are looking for the total number of seats, if we're going to add up all this number of seats from the first row, which is 20 plus 22 plus 24, 26, 28, 30, and so on up to 78, that is 1,470. Another example, for example number 3, what if we are to find the sum of the sequence 2, 6, 18, 54, and so on, up to a sub 5. So again, we have to see what are the given in the problem. So we have to identify what sequence is involved so that we can identify what formula shall we use. So given the sequence 2, 6, 18, 54, and so on. So we have a sub 1, that is 2 as the first term. And then n is 5. But what kind of sequence is it? So, upon checking the given or observing the given, we can say that this is geometric sequence. We can try if it is arithmetic. 6 minus 2 is 4, while 18 minus 6 is 12. So, there is a lot difference. So, trying the second one as geometric sequence, or finding the common ratio, 6 divided by 2 is 3. And 18 divided by 6 is 3. Also, 54 divided by 18, that gives us 3. So that's why we have this common ratio as 3. And the formula for getting the sum of a geometric series is obtained using S sub n equals a times 1 minus r raised to n all over, and all over 1 minus r, wherein n is the number of terms in the sequence, a is the first term of the sequence, and r as the common ratio. And by performing the indicated operation and simplify, again using the formula S sub n equals A times the quantity 1 minus r raised to n all over 1 minus r. So we will substitute 2 to A and then 3 for r as the common ratio and 5 for n or the number of terms. So 3 raised to 5, we start with this, 3 raised to 5. 3 raised to 5 is multiplying 3 5 times by itself. So that is 3 times 3, 9, times 3, 27, times 3, 81, times 3, 243. And 1 minus 243 gives us negative 242. So 2 times negative 242 is negative 484 divided by negative 2. Since they are both negative, that gives us a positive answer. 484 divided by 2 is positive 242. And that is the sum of the first 5 terms. So to check or to look back, the 5 terms of the sequence are 2, 6, 18, 54, and 163. If we add up all these numbers, and that is 242. I hope that I have helped you find solutions to solve problems involving sequences. Thank you for listening and God bless.